Rear Admiral Mohit Gupta, former DG DCYA. Major General Dr. Sandeep Sharma, former senior official NTRO. Air Vice Marshal Devesh Vatsa, retired advisor DSCI. And also inviting Mr. Sharat Chandra Naduru, DGM Business Development and Marketing Lead, Space L&T. Namaskar and good morning. All our distinguished delegates, members of the armed forces, representatives from industry, academia, and our valued partners, ladies and gentlemen. As India rapidly strengthens its position as a leading space powering nation, space is no longer just a frontier of exploration. It is a backbone of national security, economic growth, communication, navigation, disaster management, and military preparedness. From satellite-enabled banking transactions to battlefield ISR capabilities, our space infrastructure has become inseparable from our national critical infrastructure. And we warmly welcome you to the panel on securing space as national critical infrastructure, cyber spectrum, and EW resilience. And it is my privilege to introduce our chair and moderator for this important session, Dr. Sanjay Bahl, Director General of India Computer Emergency Response Team, leads India's national agency responsible for responding to cybersecurity incidents and strengthening cyber resilience across critical sectors, with deep experience in cyber defense strategy, incident response architecture, and national cyber preparedness. He brings invaluable perspective to safeguarding space as part of India's critical information and infrastructure. Our distinguished panelist, Rear Admiral Mohit Gupta, former Director General Directorate of Naval Cyber Affairs, is a seasoned naval officer with extensive operational cyber defense experience, has contributed significantly to strengthening maritime and cybersecurity integration within India's defense network. Major General Dr. Sandeep Sharma, former senior official, National Technical Research Organization, NTRO, with deep expertise in technical intelligence and strategic cyber capabilities, Major General Sharma brings insight into securing strategy assets against emerging multi-domain threats. And we have on the panel with us Mr. Sharat Chandra Naduru, DGM, Business Development and Marketing Lead, Space L&T. And I now request Dr. Bahl to kindly take over the proceedings and steer this important conversation on strengthening India's space security architecture. We request you, sir, to kindly close the proceedings latest by 12:25. Over to you, sir.
Thank you, and good morning to all of you. First of all, let me thank SIA-INDIA for inviting me here today, and I've been hearing SIA since morning. So for those who are Hindus, I mean SIA and Tuesday, so everything just seems to be fitting into the jigsaw puzzle well. So I want you all to think of a possible scenario. If at this very moment satellite timing signals were disrupted, if secure military communications flickered, if banking networks slowed, and if air traffic control lost navigation precision, would you call it a space incident or would you call it a national crisis? In 2026, the line between the two does not exist. For decades, we spoke of space as a frontier. We celebrated launches, counted satellites, and measured prestige. But today, space is not about prestige. It is about power, about purpose, and about partnerships. Today, power grids synchronize through satellite timings. Digital payments depend upon orbital clocks. Precision architecture, disaster response, sports, entertainment, maritime navigation are all space-enabled or space-dependent. Space is now embedded into the operating system of the nation, and yet we do not secure it with the urgency we secure physical objects, such as dams, ports, refineries, or nuclear facilities. This is the strategic gap which needs to be addressed. The first step forward is conceptual clarity that space is a national strategic sector infrastructure and probably may soon move towards being a digital public infrastructure, because when satellites fail, societies would stall. Satellites are not isolated machines in orbit. They are nodes of a terrestrial network. Their vulnerabilities are not celestial, they are human, digital, and architectural. To neutralize a satellite, you need not destroy it. It can be spoofed, jammed, desynchronized, hacked, or manipulated through compromised software updates. The most effective anti-satellite weapon may not leave a debris trail. It may leave a log file, and the most potent space attack may begin in a remote server room. So, how should we secure space? In the 21st century, space security is cyber security across all three dimensions, or 3Ds, namely defense in depth, encompassing redundant security layers such as encryption, firewalls, software assurance, etc., for securing the space segment, satellites, link segments, ground to space, and ground segment. The second D, defense in breadth, which extends security across the entire ecosystem by implementing a baseline security level across all systems, including ground stations, satellite networks, user terminals, and software. And the third one is defense in height, covering cybersecurity across the full vertical spectrum of space operations from ground level data centers to LEO, MEO, and GEO. Every command uplink is a cyber gateway. Every update is a potential vulnerability. Every vendor in the supply chain is an attack surface. Hence, our role is not merely to safeguard satellites, but to ensure resilient ecosystem through prevention, protection through 3D layered approach, and ensuring continuous monitoring as well as timely response. If cyber is the intrusion layer, then spectrum is the denial layer, and spectrum is uniquely dangerous because it is silent. No explosions, no debris, no attribution certainty. Just degraded signals, navigation drift, intermittent communication loss. In a crisis, spectrum interference can be paralyzed without crossing kinetic thresholds. Hence, the need for resilience built for persistence by frequency agility, multi-layer redundancy, AI-enabled interference detection, and cross-domain spectrum awareness. Spectrum is no longer a technical parameter but a strategic terrain. Today, cyber, space, and EW, all three have converged, demanding a unified situational awareness, integrated command authority, shared threat intelligence, and real-time cross-domain coordination. Fragmentation is now vulnerability, and integration is resilience. Resilience would mean that our systems can absorb attacks, reconstitute rapidly, and continue to function. Hence, the incentive to disrupt them decreases. Resilience is deterrence by denial, and that requires architectural redesign by it being an integral part of the design itself. We need to design for survival and not for perfection. Security by prevention alone is obsolete. We must design systems assuming intrusion attempts will occur, and this means distributed constellations instead of single points of failure, hardened ground infrastructure, quantum-resistant encryption, autonomous anomaly detection, rapid launch and replacement capability, terrestrial fallback for essential services. The objective of survivability is a shift from can we stop every attack to can we continue functioning despite attacks. Such mindset can transform budgeting, procurement, doctrine, and capacity building. For India, the stakes are uniquely high. We are simultaneously a major digital economy, a leading and responsible space nation, a regional military power, and a trusted global partner. Our digital public infrastructure, military operations, and economic growth trajectory are space-enabled. we cannot afford complacency. As our commercial space sector expands, our attack surface expands. Security and security standards cannot lag innovation. National resilience cannot depend on voluntary compliance. The ecosystem must mature in synchrony with ambition. Securing space demands 5 commitments. 1. Formal recognition of space as a strategic sector infrastructure. 2. Integrated cyber, space, EW situational awareness and command mechanisms. 3. Architectural resilience through redundancy and distribution. 4. Mandatory security standards and baselines aligned with commercial growth. And 5th, a deterrence posture rooted in survivability and rapid recovery. This is not about militarization of space. It is about stabilizing national power so as to prepare for the next global order while steering power responsibly, with purpose and through partnerships. Thank you. Today, we have a very powerful panel here. We have people from all the 3 forces, Army, Navy, and Air Force, and the industry. I'm going to try and pose a few questions to them, and let's see where we are headed towards and what are their views on this subject. So with your permissions, I'll ask the first question to General Sandeep Sharma. So, should space systems be formally designated as national strategic sector infrastructure, and what changes would that trigger in funding, protection, standards, accountability, etc.?
Thank you, Chair, Dr. Sanjay, and is it okay? Okay, thank you. Thank you, Chair, Dr. Sanjay Bahl, my co-panelist, and ladies and gentlemen. Before I answer whether space should be a national critical information infrastructure, just you give a brief scenario to come on to this, to answer this question. So I'll say, imagine a...
Is it audible?
Is it okay? Hello? Hello? Is it okay? So imagine a cyber intrusion that silences NAVIC for a few hours, let's say 24 hours or 48 hours, or a malware attack which grounds or breaks the modem which are relaying signals from the satellite to the users, or let's say a jamming which blinds up border surveillance satellites during heightened tension, or an EW attack that turns a 500 crore satellite into a debris drifting across in the space, or things like that. So these are no more sci-fi movie clips, but they are actual things which are going to happen in near future. So space is no longer an exploration alone. It is the backbone of our digital economy, and with 300 Indian space tech startup with a target of good about 44 billion by 2033, and constellations supporting everything from BharatNet to border surveillance, border security, space has become de facto a critical infrastructure. As per IT Act 2000, amended 2008, critical information infrastructure, what is the definition? It says computer resources, the incapacitation or destruction of which shall have debilitating impact on 4 things: national security, national economy, public health, and public safety. These are the 4 parameters. So this is the formal definition. I've been normally speaking informally. What is critical is which affects the day-to-day life of a citizen. So if a citizen, if I don't get electricity at home, if I can't speak to my friends, if I can't draw money from the bank, or there's no power in the house, things like that, it is a critical sector. So over a period of time, there are 7 sectors which have been defined national critical information infrastructure. First is the BFSI, and that is banking, financial services, and insurance. Then you have government, well understood. So you have UI, DAI, NIC, part of that critical sector. Then you have strategic and public enterprises. ISRO comes under that. You have health, transportation, telecom, a very important critical sector. The Section 70 of the IT Act 2000 lays down appropriate government may, by notification through official gazette, declare any computer resource which directly or indirectly affects the facility of CI to be protected system. What does it mean? If I declare a system as protected, what does it entail? It entails that anybody who tries to touch it illegally, even he may not enter your system, even if he tries to explore your system, the punishment is up to 10 years of jail. So as on date, we have roughly about 123 protected systems, CIIs, and about 500 protected systems, total making it about touching about 780. There's a figure which is going on. Now, whether space is to be treated as national critical information infrastructure, there is already a critical sector which has been defined as strategic and enterprise, under which ISRO has been declared, and there are 4-5 systems of ISRO which have been declared as protected. TTNC, then Space Launch Centers and others. I don't remember the complete list. The list is with me. I will not list out from there. There's no effect on the funding part of it. The provider of the critical infrastructure remains responsible for its safety. That has to be made very clear. The agency which is looking after the CII, that is NCI IPC, is only responsible for monitoring and advising. But the overall responsibility of protecting themselves lies with the agency which is providing that service. So if you look at it, I've just noted down the modern society, because I have to define it on 4 parameters: security, safety, public health, and national security, health. So the modern societies depend on satellite for, everyone knows, navigation, communication, weather forecasting, banking and financial transactions, aviation and maritime navigation, power grid synchronization. And in military terms, we are here for the DEFCET. So the space enables precision strikes, network-centric warfare, real-time battlefield awareness, and secure strategic communication. So disabling space assets can paralyze a nation without even firing a traditional shot. So if we don't want to call it as a national critical, but space is a strategic asset. Thank you.
Thank you. That was a fairly detailed explanation, and with that, from the land, I'm going to move towards the sea to Rear Admiral Gupta. Should, in the light of tourism, private players' entries, military, etc., should India consider a unified cyberspace security operations center, integrating defense cyber agencies, space operators, and civilian CERT frameworks? What are your views?
Good morning, everyone. Good morning, Chair and co-panelists. First of all, thank you to SIA for inviting me to sit on this forum. We have seen the use cases of space, and the list is ever growing. It is vital for the national security sector, it is vital for societal development, and it is vital for national economy. And of course, when I say society, things like entertainment and tourism are included as part of it. So since space is a great enabler for all these things, it is important. And the biggest thing today which is affecting space is the possibility of a cyber intrusion, right? The second thing which you have One is that when you have a space awareness center, so you are monitoring whether the satellite is going on its intended path or not. There are so many space debris or other satellites, announced or unannounced, which are roaming all around. So we should have robust space situational awareness. One is that you are able to prevent collisions by diverting your path if something comes through. And secondly, planning your satellite trajectories in the ever-growing mass of space objects which are floating all around. So one part of a situational room would be the SSA. The second part is that everything which is there in the space segment today, whether it is in the satellite or in the ground segment or the links thereof, is connected via digital links. And we all know that digital links can be manipulated by cyber players. So, if we want to ensure a robust security for an architecture like this, it has to be an integrated play between the space and cyber. Today we have satellites largely in the civilian domain, which are controlled by ISRO. Very soon we are going to see a large number of Indian military, or so to say, security application satellites or dual use satellites which will go up in space. Space-based assets are very, very costly. So the nations cannot afford multitude of satellites going up in space. And when there is a requirement, they would be dual tasked. So space as a sector combined with cyber, I think there is a fit case to ensure that there is great synergy amongst the civilian and the defense players in this, as well as there is agencies which are responsible for ensuring our security in the cyber as well as space. So I am personally a votary. We should achieve greater civil military fusion in this and also amongst the space and cyber agencies.
Thank you. So let's go into the air now. So my question is to AVM Dr. Vatsa. So what constitutes an act of war in space? And is cyber intrusion into satellite equivalent to physical damage?
Very good afternoon to everybody, and thanks, Chair, for allowing me to sit with you. And all the gurus are sitting here because Mohit sir was my boss in DCYA, and NTRO, I should use now words, sir, you have now retired, sorry. But he was always advising me what you are supposed to do when the cyber intrusion takes place. And Bahl sir, my association goes 20 years back. But interesting part is this, the question itself is very, very, you can always agree on this part, because since morning we are listening only one thing, that SATCOM can do this, SATCOM can do this. It can provide you precision strike, it can provide precision agriculture, it can provide you communication, it can provide you disasters, it can help you there. If everything depends on the SATCOM so much. So I think defining it as an act of war is appropriate, but there is a constraint. The check is this, when we talk about act of war, there is no single agreed legal definition of war in space. And why it is so? Because states interpret space action through existing international law frameworks, especially we have got a 1967 Outer Space Treaty. Then we have got United Nations Charter, Article 2.4 and Article 51 on use of force and self-defense. So if we talk about this, the customary international law on use of force and armed attack, under prevailing interpretations, an act of war in space would likely involve two things. Like A, it is use of force. Any action that causes physical destruction of a satellite, produces kinetic debris, disables critical infrastructure, causes injury, loss of life, or significant economic disruption. Just an example, like a kinetic anti-satellite, ASAT, strike like the 2007, when Chinese ASAT test against the Fengyuan 1C satellite, widely cited in a strategic debates. This is one aspect. you are damaging your own satellite or damaging somebody else's satellite, but the debris you create can create a situation in the orbits. Then, when we talk about all these things, when this kind of damage takes place, when we talk of life and when we talk of critical infrastructure, which is dependent on the satellite, on the military aspects, I think it becomes an act of war. And if we say so, what could be the strategic bottom line on this? So I feel a cyber intrusion into satellite is not automatically equivalent to physical damage. But if its consequences are comparable to kinetic attack, if it produces lasting functional destruction, if it crosses strategic thresholds, then under evolving state practice, it may legally and operationally be treated as an act of war. And why I'm saying so, if you see in 2016, America decided that cyber attack will be responded by a kinetic response. And in 2019, they said space is a war fighting domain. And they created US Space Force, and the China, when they created a rocket force, they're doing the same thing. So if that is the situation all over the world and all over the powers which you think they can create damage to your own satellite or anything they are powerful enough to do, I think it is an act of war when you bring any national security aspects to a paralysis. Thank you, sir.
Great points. I'll go towards the industry now, to Sharad. So is disaggregation of many small satellites more secure than a few high-value assets? What are your views on that?
Sure, sir. Thank you for that question. Firstly, I would like to say that it's really a pleasure to be on the panel with such a lot of experience of serving the nation. I'm really proud to be on this panel. Thank you for this opportunity, Chair. So, to answer this question, sir, I would like to bring out three key aspects that help us by having more satellites rather than having one big satellite. First, being the redundancy part. Second, being the mesh architecture. And third, being rapid launch capabilities. So today we have seen that in the recent times during the Ukraine-Russia war, when certain SpaceX satellites were being jammed or spoofed by the Russians, they could quickly, because of the mesh architecture and the intersatellite links, could use other existing satellites to provide the required communications in a very quick manner. So that is possible only if you have many small satellites. And secondly, so that is where the redundancy and mesh architecture builds in. And when certain specific assets are targeted, by having small satellites, we have a rapid launch capability that we can associate. So because compared to a 1-ton satellite may take around 7 to 8 years to make, but compared to that, a 100 kg or 200 kg satellite can be done in months. Right, and also the launch. So with SSLV, Skyroot, and Agnikul coming up with their rapid launch capabilities, I think that makes more sense that we have more number of satellites wherein they are more resilient, have more redundancy, and also provide continuous service and be capable of quick turnaround.
Great points. I'm coming back to you, General. Why do you think resilience in cyber, EW, and spectrum matters now? And what is your view on how exposed are space systems to cyber threats? And what are some lessons for India's space sector from recent incidents?
It's an important question as to why is resilience now important, right? We have started talking in terms of creating resiliency in space. There's no doubt that our dependence on space has increased, exploded in fact I should say. GSAT, NAVIC, and soon to be launched constellation of 52 satellites under SBS-3. These are not just satellites, they are the force multipliers. And there's no doubt that the satellites are a force multipliers, but that also has increased our attack surface. We'll well appreciate. I'll speak about the attack surface in detail, if time permits. Come to cyber threats, the invisible seas which takes place. Being DG CERT, you'll be well aware that I know that ISRO faces hundreds of attacks every day. How many become successful is a separate debate, but the attacks are attempts are on a daily basis. Legacy systems on older satellites, unpatched software in ground segments, and third-party components create entry point for intrusion. So a successful compromise could mean loss of command, data infiltration, or even satellite hijacking through various means. Now, I'll try to cover the three segments, the ground, the space, and the user segments. The firstly is the ground segment. That's the weakest link of entry into the complete system by itself, right? The key threats, leave aside the three segments. So as far as cyber intrusion is concerned, you can have hijacking of command signals, data interceptions, malware in ground systems, electronic warfare. We'll speak on EW and spectrum at a later stage. Example of ground segment is the famous on today, that is 24th of February 2022 it happened. That is the Vice President Commercial was also present here. The famous satellite interception of Ukraine which took place, the Viasat, I can be clear, the example which is normally given. 23rd of February, the login attempts took place from Italy. It became successful by evening through a VPN. And early morning at 5 of Ukraine time, that is India's 10 o'clock, exactly 4 years back, this attack took place where about 1,000 modems, satellite modems were bricked in Ukraine and roughly about 30,000 across Europe. And by the evening, the invasion went in. So what happened? It affected the military command and control system, communication system. It took time. The modems could be replaced only by mid of March. So you can imagine the delay which took place there. So this is a classic example. Now another example which is very valid and is the attack in 2017, North Pattaya. So he is smiling. The same thing, these are examples for the space to become careful now, right? How can unpatched software exploits can create havoc, and through ground segment they can access the space segment, and the user segment in any case remains vulnerable always. So this is about cyber as such. Coming on to the spectrum, there's a heavy contested sphere, especially in the Ka-Ko and Q/V band. And over a period of time, the spectrum will be limited. There will be too many people vying for a limited spectrum. And then is the EW, where you have the jamming and the spoofing. So the difference between the two is, in one case the signals are blocked, in the other case the signals are manipulated, so that the weaker signals get overridden by illegitimate signals, and you are made to believe that what you are seeing is correct, which actually is not there. And November mein incident happened in India of the spoofing along the border, and 7 major international airports mein this happened. So if you look at all these threats which are emanating now, which are becoming real, resilience becomes important.
Sir, may I add something on that part? Like when he was speaking about the Viasat incident,
Very interesting aspect is this, gentlemen, an impact in the space, what it can create on the ground. I don't know if you must have read about the entire report about this Viasat thing. 5,800 nodes of wind turbines. The communications was halted. and you understand that when you are generating a power, it is to be controlled, how much power you push to the grid, and the control is out, what damage it could have done. So imagine all over the Germany or Europe, for example, 5,800 nodes as reported in one of the reports, they got affected. So there was nobody and no control was there on what they are producing and what they are pumping to the grid. And you know, in the grid, it is a synchronization which takes place, the synchronized control will go. So if you keep on pumping the energy which is not needed, it can create disaster. Just to add to it, how it becomes so important today to safeguard the space. Thank you.
I'll just add to this. I'll give you another live example. DEFCON. I don't know how many of you ever attended a DEFCON in Las Vegas. I'm talking about DEFCON 2023. I've attended through two of them. With the US government approval, the pen testers, there are roughly 18,000 people who assemble in that city of Las Vegas to try their hands on hacking the best of the systems in the world. So it was allowed by the US government. So they demonstrated on a live in-orbit satellite 3 things: privilege escalation, lateral movement from bus to payload, battery drain, and GPS coordinated tampering and service shutdown. This was actually demonstrated in 2023 DEFCON.
I think you have beautifully articulated why resilience is critical and why it is required. And with this last example of pen testers, it just cements everything. Knowing that Dr. Vatsa is eager to speak, I'm going to take the next question to him. So what do you think is the minimum viable resilience India must achieve in the next 5 years? And any suggested way forward for the resilience framework? And I'm adding to this is, what do you think is the single most urgent reform India must undertake in the next 5 years?
So there are 2 questions, sir. So first, India must ensure, the first question, the answer what you are asking is that what India should do, or what should be the minimum viable resilience India must achieve by 2030, if I may say so, because you added 5 years to that. But the important aspect is that India must ensure that no single counter space action, that is cyber, kinetic, EW or spectrum, can blind or deafen or paralyze national decision making or joint military operations for more than 24 to 72 hours. So that kind of resilience you have to develop. And that is the threshold of minimum viable resilience. And when we talk about what it means actually, it is the ability to absorb a first strike. Attack will take place, but how you are capable and able to absorb that. Then maintain core mission continuity. That is very, very important. Then third aspect is rapidly reconstitute degraded capabilities. If your capabilities are getting degraded, how quickly you come back again, that is the game. Then deny adversary escalation advantage. I think this aspect is very, very important. And when we talk about, if you ask me 5 pillars, if I say, what are the 5 pillars of India's minimum viable resolution by 2030? So it is assured mission continuity, no single point of failure. Then we talk about cyber hardened space architecture. Then we talk about spectrum and electronic warfare immunity. That is very, very important. And the fourth aspect is space situational awareness and attribution credibility. Then the last, rapid reconstitution capability, which I mentioned. And when you say so, what should be the single most urgent reform India must undertake in the next 5 years? So I will say, establish a fully empowered, legislatively backed National Space Security Authority, which integrates with cyber and electronic warfare command structures. Thank you, sir.
You got the election season coming close. Dr. Vatsa making a pitch for that. I'm going to go into a little bit of technology now, and I'm coming to you, Rear Admiral. What role do you see AI would play across cyber, space, and EW going forward, since we've just completed the AI Impact Summit? So I thought this would be a pertinent question to ask you.
Thank you for that timely question. AI seems to have become a buzzword these days. In fact, it is today the biggest technological disruption which is taking place in our lives. And if I may say so, it's as disruptive as the humankind's discovery of the fire, or maybe, how do we use it, that kind of stuff. So AI can be used both for defensive purposes and for offensive purposes. So I'll just take the use cases for how AI can be a great enabler in defensive roles. One is that when you are doing, for example, when you're doing image analysis, till now the systems work on standard algorithms, right? You are, for example, there is an image of a satellite which is there for a particular area. Now, object recognition, which the AI can do, is multiplied multifold by having an AI-powered engine in that. Similarly, a picture comparison. What changed over a period of time, right? The second application of AI from a cyber point of view can be that today, everything, whether it is the firmware which goes into the various modules of the satellite, the firmware which is there embedded in the ground segment, or any other systems which are software dependent, there is a code which is there. How do you check the code? I mean, we say that the code has been cleared. We do vulnerability assessment and penetration testing. Now, we've recently, if you've been following, Cloud just released a sort of a platform where you can check code at scale, vulnerabilities which have not been detected by legacy systems or legacy checkers and human beings have been discovered now very, very fast. So you can do both static and dynamic analysis using your AI codes. And as we say that vulnerabilities which are not available today will be discovered tomorrow. So what has gone in the space? You have, space systems which have life of 15 years. So if they've gone all okay today, it is not that they'll be all okay tomorrow. So you have to use those AI systems both before launch, in the preparation, and whilst they are in orbit to check that if there is any intrusion of malware or not. Similarly, sometimes what happens is that human beings are not, or legacy systems are not capable of recognizing behavioral changes which take place in your cyber systems. If there has been a cyber intrusion, there is a time lag from the intrusion to the time you detect it and mitigate it. The AI systems can make it much faster. If there is a EW sort of interference, whether it is in the form of jamming or in the form of spoofing, both from the user point of view, that he is being spoofed or there is some interference which is taking place, as well as to the asset which is radiating that information, it can provide answers to that. So that is a great use case of AI. We talked about achieving resilience. Now, if you are jamming, so what happens is that normally you employ frequency agility or spectrum techniques. If you incorporate AI into that, both from a defensive point of view as well as from an offensive point of view, it can help you in achieving greater outcomes, right? More so from a bad man's point of view, I think AI can be used to write code at scale. It can create exploits at scale. You can have multiple bots, multiple points of entry to intrude into the systems. And the fact is that if something gets caught, you can change the exploits at scale. So that is the overwhelming kind of an attack which you can put on that, and you can test the resilience. Because even the resilience which you build into the systems, first of all, let me tell you that when you make resilience into any system, it costs you money, right? So when you build resilience in a system, it is considering a particular aspect, that this is the scale of attack I can expect. But AI can generate a scale of attack, both in terms of range and scale, which can overwhelm all the systems and achieve massive asymmetry. I think these are the aspects which need to be kept in mind.
Thank you. That's scary. and that's also useful to understand what we need to do. Coming to you, Sharad, are we moving fast enough towards quantum-resistant encryption in satellite communications? What are your views, and what do we need to do, and what should be the timelines?
Oh, thank you for that question, sir. Very apt. So, before we understand whether we are moving fast relative to others, if I can throw some light on why we require this. So, so as we have been discussing, the resilience forms the main backbone for the architecture that we should have for our space assets. And for the resilience to work, one of the key main components is to have quantum encryption. It works on the principles of quantum entanglement, which are like unbreachable as we know of, and that is something which we should mandatorily have going forward, along with edge computing, which Sir spoke about, for having a resilient space architecture. Now, coming to whether we are progressing in the pace at which we are, definitely before we are much ahead than what we were 2 years back, but our neighbors are doing much more. So today we have already, I think, established between DRDO and IIT, there was a quantum key distribution established for 100-kilometer ground to ground, and the next step is to do ground to space and then to space. But we know that China has already launched 2 satellites which are for testing the quantum key distribution. So the pace at which we are moving needs to be much more accelerated, and we need to involve more academia and industry to accelerate the pace and catch up at least with where the adversaries are. Thank you.
Excellent. So we've had a very disciplined, patient, and attentive audience. So I'm going to open up the floor for a couple of questions and then come back to the panel. So maybe if anyone wants to ask any 1 or 2 questions to any of the panelists. Yeah, I see one hand. You can speak loud enough.
Just a request, can you again cover this 5-pillar?
So your ticket to the elections is done. Okay. In the meanwhile, any other question? Yes, there's one from here. It's working.
Yeah. My question is again on quantums only. I personally feel we are lagging very behind, way behind. And also, the infrastructure to support that type of quantum requirement is not there. So I would like to know the views. Where are we going? Thank you.
And there was one somewhere here, yes. I'll take, that's the last one.
Yeah, hi. So we talked a bit about the supply chain attacks as one key pillar of how satellites can be breached. So what are the steps or what are the careful measures that we are taking as a country to ensure that the supply chain attacks do not happen? Because some of the components, because that would also kind of mandate that we check the hardware, the software, and also the origin country of those parts where whatever goes into the satellite. So.
Yeah, you're talking about trusted supply chain. Okay. So I think, Dr. Vatsa, you can start with the first one.
See, in the domain of globalization, you cannot create your own infrastructure using your own components. This you will agree with me, right? So how do you evolve in this dimension, and how you address this? A, what you said is right. There has to be some lab infrastructure which can test everything, whether you talk about hardware, software, firmware. But it is not possible to check each and every component. This you also agree. And the way we define in the cyber domain, 3 aspects, 3 pillars. The people, process, and technology, right? You have to understand when you are buying a technology from outside, you don't trust it. So what do? You decide some kind of policy on that, how you will control that kind of a thing. Example I'll give you. When Indian Air Force made their first captive network, we used the Cisco routers and switches, right? So what do we do when there is a fault, when the equipment is to be replaced? We never allowed the vendor to enter our premises. We never sent our equipment to them. We never went online for taking any update. So what we did, we decided a policy that if anything goes down, you will bring a component here and we'll remove and keep it with us. So there is a methodology on doing this. Yes, having said this, this is a very passive way of doing it, but the active way is you should have, like we have got a STQC lab in Calcutta, right? So, but it will give you a EAL4 certification. There is evaluation assurance level 4, which goes up to 7. But in India, we are able to do it. There is a common criteria on the aspect which you were saying on the testing aspects. For example, when it goes to the defense, then you got another layer. You got a SAG, you have to take an approval, and then it will go into the defense equipment. So yes, it's a challenge. And sorry to say, but it's a fact that states are involved in putting beacons into the system, which are being thrown to the entire world. And because there is a reason for it. When they desire and when in their need of hour and the choice of time, they can damage the system. I'll not name, but you know it well, very well. And if you want to know more, please read a book, The Perfect Weapon.
There are only two things for this. Trusted sourcing for critical component and mandatory vetting. Without that, supply chain will always remain a vulnerable point of entry.
And sir, somebody asked me the 5 pillars. Sir, you asked me this? Yes, sir. So first is the assured mission continuity. That is no single point of failure. This means what? Like we talk of NAVIC, we should have satellites, enough numbers. Then we talk of strategic communication, ISR, missile early warning network. Everything should not fail. Because if it fails, this means you have not created a design in a manner that system is resilient, which sir has spoken at length. The second aspect is cyber hardened space architecture. So this means what? Secure by design. When you are designing any component which is going into the space system, it is difficult there to do. So if you do that, you are quite sure that your system will work the way you have designed it. Then the third point is spectrum and electronic warfare immunity. You have to again design a system which Jan Sharma has spoken about how the electronic warfare and spectrum plays a role. How you harden the system so that they are not affected. And yesterday only I got one of the startups were talking about how they can make your system jam-proof, right? So people are working in this domain. Then the fourth one is space situational awareness and attribution credibility. This is very, very important, right? And the fourth aspect is rapid reconstitution capability. When I say so, during war or even somebody damages your satellite and which is giving you some kind of functionality, do you have that capability to launch satellite on demand? Can you replenish it at a faster rate so that your functionality is still achieved? That is what. Thank you so very much.
So I will request you to answer on the quantum, please.
Okay, as regards the quantum aspects are concerned, we all are aware that there is a national quantum mission which is there. But we haven't seen any tangible results coming out from there. There are many aspects to quantum. One is that we are in the quest for making a quantum chip or a quantum computer. Second is to make a quantum safe algorithm. Third is QRNG or quantum random number generation. And the fourth can be quantum key distribution. And I'll just tell you where we stand based on open source information. As far as the quantum chip is concerned, now when you consider the efforts of the Chinese or Google, I don't think there is much to carry home from what we have achieved in India on the quantum chip or the quantum computing front. We are a long way from there. There are many institutions, both in the public and private sphere, which have generated QRNGs. And as you know that the present day cryptographic algorithms, they can be strengthened if you have a true random number generation, which happens via QRNGs, which are already deployed. The third thing is QKD. Now, as my co-panelist just informed you, that QKD communication has been achieved over distances. It has been demonstrated. DRDO, ISRO, LNT, many academic institutions have been working on it. Now, for quantum key distribution, essentially what matters is that at what distance is it stable, right? So we have achieved certain distances but have we achieved it at long range through, let's say, geo satellite links or something? I'm not aware publicly of any communication taking with the geosat using the QKD. So there is work which is going on. It's a promising field. The last, but the most important thing is that have we achieved a quantum safe algorithm like crystal fiber or something which is thereby which was which is commercially being used? Sadly, no. We are very, very far away from generating a quantum safe algorithm. And when it comes to government cryptography, so one is the commercial cryptography aspect, second is the government cryptography. The algorithms which are used in commercial cryptography are not employed in government cryptography. They are grade A algorithms. So if we have not achieved something, which the Americans achieved in a competition many, many years back, and they have a plan where quantum algorithms are even going to be used for commercial applications, I think we as a nation with so many brains, we need to put in some extra efforts on that.
Thank you. With that, I'm going to wrap up this session by just giving some closing statements. What we understood while we talked about technology, law, process, etc. Space is no longer a safe zone. It is an infrastructure. It is a battlefield. It is an economic backbone. It is a strategic high ground. Securing space is not about militarizing it. It is about safeguarding the foundations of national power. The real question is not whether conflict will extend into space, but whether resilience will precede it. And as I mentioned in my opening remarks, it is about stabilizing national power so as to prepare for the next global order while steering power responsibly with purpose and through partnerships. Thank you. I would like to thank all the panelists here for giving us such wonderful insights and for the audience for being so patient. Thank you.
Thank you very much indeed, sir. I would request Dr. Sanjay Bahl on behalf of the organizers to kindly do the honors of presenting a token of gratitude and appreciation, a memento to all our eminent panelists. I request you, sir, to honor Rear Admiral Mohit Gupta. Thank you, sir, for being here with us, for all those valuable insights. To Major General Dr. Sandeep Sharma. Thank you, sir. To Air Vice Marshal Devesh Vatsa. And to Mr. Sarat Chandra Naduru. And may I invite on stage Mr. Pawan Kapoor, Board Member SIA-INDIA, to kindly do the honors of felicitating our distinguished chairperson of this session. And I would request all our dignitaries to kindly come together for a group photograph of the panel. Mr. Kapoor to kindly join the panelist. And ladies and gentlemen, let's once again put our hands together to convey our thanks and gratitude for all those valuable insights shared by all our eminent panelists in this session. We would request everyone to kindly remain seated as we straightaway move into the proceedings of the next session. Just give us a moment while we arrange the top table for the next session.